So, by the end of class today, you will be able to take the sine of an obtuse angle. You might say, I can already take the sine of an obtuse angle, and I would say, okay, tell me what does this mean? Sine of 150. Up until now, when we've been doing sine, what does that mean? Sine of an angle is going to give us, all right, that's correct, a ratio of, to be more specific, the length of the opposite side of the triangle divided by the length of the hypotenuse of that triangle. Okay, well there's a triangle. There's a 150-degree angle. I went ahead and put some other numbers there for some sides, 8 and a 20. Now how would we go about finding the sine at this point? Where is the opposite side? So the opposite is the hypotenuse?
Oh,
wait a second.
The answer, but
okay, wait, all right, so the opposite would be, normally it's the side that's across from that, that's correct. However, that's the longest side, and I always thought the longest side was the hypotenuse, right? Okay, so does this one have a hypotenuse?
No. It has a hypotenuse.
Actually, it doesn't.
Oh, it doesn't.
It doesn't. A hypotenuse, by definition, is the longest side on a right triangle.
Oh, on a right triangle.
oh, so it doesn't matter.
We don't even have a right triangle. That's why several weeks ago when I started talking about this, I said this is right triangle trig, okay? Because it was dealing with right triangles. This ain't no right triangle.
So hypotenuses are only on right triangles. They won't be on any other.
That's right. It's a, by definition, hypotenuse is on right triangles. It doesn't make any sense. In fact, the opposite, the technical, the full word here would be the leg opposite the angle on a right triangle. So there isn't even an opposite, because technically an opposite is the it's the opposite side. So for all practical purposes, can we find the sine of 150? No, we can't find it. There's problems. Now, so that tells you we've got some limitations about what we can do with sine, cosine, and tangent. Namely, we can find sine, cosine, and tangent if the angle is, what type of angle do we if there's a right triangle, and we're looking at one of these angles right here. Now, by definition, they're going to have to be acute. Okay, 90's here, then the other 90, because it add up to equal 180. The other 90 is split up into two angles. So the biggest this could possibly be is 89.9999999. This is 0.0001, but it's still going to be acute. That one's still going to be acute. If I said that's 30 degrees, you're like, no big deal. That's the opposite. That's the hypotenuse. You give me some numbers here, you give me some numbers there. I can plug it in. I can tell you what that's going to be, no problem. Okay? But we deal with this sine of 150, and there's some issues. Okay? So the problem is our definitions are too narrow. Okay? When I say what's the sine, and you say the opposite over the hypotenuse, that's only dealing with right triangles. That eliminates the possibility of having an obtuse angle. So what we need to do is we need to broaden our definition of sine, cosine, and tangent. Okay? We need to have definitions that will include the ability to take sine, cosine, tangent of 150. Your calculator can do it, okay? Because the people who wrote a calculator know the bigger definition of sine, cosine, tangent. And when we make this bigger definition, it would be really nice if it works in such a way that it includes the definition of opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, okay? If you're familiar with software and programming, how all that stuff works, your MacBook and also like Windows computers, they have a program that sits on the computer itself all the time called the operating system that allows you to open up files and run programs, stuff like that. On the Macs, it's called OS X. On Windows computers, it's called Windows. But there was like Windows 7, then there was Windows 8, then there was Windows 10, if you all remember that, okay? What was cool is that they made it so that if you upgraded your computer to Windows 10, your programs that were on Windows 7 would still work. Okay? In other words, it was backwards compatible. Okay? That meant that your newer operating system could run those older programs. Every year it's in the fall, they do an update with the operating system. If you've ever had a phone, sometimes with your phone you'll get updates on the operating system. You'll be like, would you like to get the newest version? And the answer is no. I want to wait a couple months till all the bugs get worked out, then I'll upgrade to the latest operating system. That's what you want to do. But anyway, we want to make sure that our big definition, our new definition of sine, cosine, tangent incorporates this and is backwards compatible with our right triangle trig. Okay? So what we're going to do is we're going to develop it right here, and then together we'll make a nice little formula sheet that you can copy down somewhere, make it real nice. So let's go ahead and draw that 150. And I'm going to actually put a terminal point right there. I'm going to say this 150 degree rotation, it stops at some coordinate x, y. I don't know what it is. It could be -520, or it could be -316. I don't know what it is, but whatever it happens to be, we know that that x value is right there, is going to be this distance, and that y value is going to be this distance, and all of a sudden things are looking kind of interesting. You're kind of like, I know that the x and y axis are right angles to each other. What do you see we just created? A right triangle, that's correct. And if we think about this angle right here, which is 30 degrees, also had a special name, we talked about it yesterday, that's the reference angle, okay? Then it is 39. Now that's just a happenstance, okay? That's just, this is going to work no matter what angle. I just picked that for ease of calculating. All right? And what we can start doing here, we can start looking at some interesting patterns here. All right? So across from the 30, that's the opposite. Next to the 30 here, there's the adjacent. Here's the hypotenuse. And mathematicians have got into the habit of calling the distance from the origin out to this point right here r, because it's sort of like the radius. From the origin out here to that coordinate. So what we can do already, what we've known, what we've been doing for a long time, is we can talk about the sine of 30 degrees. That's going to be the opposite over the hypotenuse, right? So if we think about that in terms of these x, y's, and r's, the opposite is the y value, and the hypotenuse is the, nope, the hypotenuse right here,
Hypotenuse is r.
is the r, okay? And so what mathematicians did is they just said, you know what, that y and that r, I really kind of like that. In fact, that's what we're going to declare is the sine of 150. If you want to figure out what the sine of 150 is, then let's just find out what that y value is at the terminal point and divide it by the radius, the r, that would connect the origin to that. And that's going to be our new definition here for the second quadrant for dealing with sines of angles over there. Okay?
The answer is
Y over R is how they decided for that second quadrant to do that new definition for sine.
Okay.
Okay? Cosine of that 30, we all know that it's COA, adjacent, or sorry, not COA, CA, so CA, TOA. Adjacent over hypotenuse. What would that correspond to in terms of x's, y's, and r's? X over r. And so like I said, the mathematician said, hey, let's redefine for cosine in the second quadrant, let's call that x over r. Tangent, TOA, opposite over adjacent. On here, y over x. And so they declared that shall be, I mean, they've got to make some decisions. They're like, we want to be able to take sine, cosine, tangent. How are we going to do that? Okay, well, let's just rename it. I mean, there's a lot of relationships here between the 150 and the 30 because we've got that triangle right there. Let's go ahead and do that. And that works out great for the second quadrant. Okay? Y over R, X over R, and Y over X. So then the question is, okay, great. What about the third quadrant? Let's see what happens if we have an angle down there. We'll do something that's clearly not special. So 180 plus 40, so 220. And so if we ended at this coordinate, x, y, then we can see that means we walked to the left some x coordinates, and we've walked down y coordinates. Once again, very interesting. We happen to find that we've made a right triangle. What's the angle measure right in here, this acute angle? 40 degrees. Kind of interesting, that's the reference angle that we talked about. Yeah. And if you're looking at this particular triangle, in reference to the reference angle, what does the x correspond to? Which side of the triangle? Adjacent. So again, that x, that back and forth is adjacent. The y, the up and down, is the opposite. And the hypotenuse is the hypotenuse. They decided to call that r. Ooh, that's kind of nice. X, the x value, the left and right there, that was the adjacent. That's the same thing that we had over here. Ooh, the y value, the up and down, that was opposite. That's nice, because that's what we had over here. So we could say the sine of 40 degrees, which is the opposite over the hypotenuse, that's going to be the same thing that we saw over there. It's the y value over the r value. And so we are going to declare that that is the sine of 220 in the third quadrant here. Cosine is adjacent over hypotenuse. So the adjacent is the x, hypotenuse is the r. That's the cosine. 220. Awesome, nice. We're getting some consistency here. What about tangent? Tangent of 40? Opposite over adjacent. Opposite is the y. Adjacent is the x. Once again, consistency. We're finding out for those two quadrants, our renaming of sine, cosine, tangent in terms of y's and r's, it's all the same. Okay? But we need to be consistent here. We're going to check it for the fourth quadrant, and then we're going to go back and check it for the first quadrant, make sure everything's 100% backwards compatible. So what's an angle here in the fourth quadrant? What's that? 340, sure. That's going to give me, I think, a 20-degree reference angle. If we stop at coordinate x, y, once again, that means I walk horizontally x and then walk down vertically y. I can see a nice right triangle here formed by the reference angle. Talk to me in reference to that 20 degrees, what is the x? It's the adjacent. All right. And what about the y? Opposite. And the hypotenuse is the r. Well, that's really nice because this is matching the exact same situation that I had here, where the x is the adjacent, and the y is the opposite. Are you okay without writing all this stuff down all over again? Okay? But y'all can see that it's a match. That means that opposite over hypotenuse is still going to be y over r. Adjacent over hypotenuse is going to be x over r. Tangent is opposite over adjacent. It's going to be the y over the x. And so if we look at the last situation, when you're in the first quadrant, and you stop at coordinate x, y, that means you've gone over x, you've gone up y. Well, the reference angle, this is 55 degrees. The reference angle is that same angle. So talk to me, what about this x right here in relationship to this triangle? Okay, it's adjacent. The y value, the up and down, is the opposite. And of course the hypotenuse, once again, is the r. So that's great. In every single one of these cases, if we look at our angle in relation to the reference angle, the x is always the adjacent. The y is always the opposite side, okay? So that allowed the mathematicians to say we are going to broaden our definition of sine, cosine, and tangent. It is no longer going to be opposite over adjacent or adjacent over hypotenuse. It's now always going to be described in terms of x's, y's, and r's. Okay? Now, can you still draw the right triangle and figure out adjacent? Yeah, you can still do all that stuff if you want to. But you don't have to. If you just know x's, y's, and r's, then you're good. So here are the new trig ratios. Sine of theta, y over r. Cosine theta, x over r. Tangent theta, y over x. Might as well just tell you the reciprocal ones as well while we're at it. Cosecant theta, remember it was just everything was switched, flipped rather. So r over y. Secant theta, r over x. And cotangent theta, x over y. This is going to work every single time, okay? If you have that terminal point. Also, it's going to handle when you're in that first quadrant, and it's going to be able to handle just your basic, opposite, adjacent, hypotenuse, stuff like that. So those are the new definitions. They're expanded, and this allows us to take the sine, cosine, tangent of angles of rotation even bigger than 90 degrees, okay? Questions so far? So, I want us to think very quickly about when are they going to be positive and when are they going to be negative, because that's the one thing that I haven't really mentioned to you very much, is that this is going to give us the opportunity now, since we've got stuff in other quadrants, the x's and the y's are sometimes negative, okay? When we were dealing with just old regular triangles, everything was always positive. We had a triangle like that, and you had 20 degrees right here. This was positive and this was positive. But now, notice, if we're kicking off over here to the left, we've got the fact that actually that x right there is going to be negative, and that y is going to be negative. And if we've got those over values, and this one right here, that y is going to be negative, we're going to end up with some sine, cosine, tangent values of things that are going to be negative. So let's talk about that real quick. In the first quadrant, if we have the sine, we just said a moment ago, that was y over r. Now, in the first quadrant, y is positive because we're up here, okay? X is positive, okay? And in all four quadrants, R is always positive. So let's think about the sign. It's going to be the y over r. So a positive over a positive, which is positive. Cosine. It's the x, which is positive, over the r, which is also always positive. Positive over positive, positive. Tangent. Y over x, so a positive over a positive, also positive. First quadrant's kind of boring, actually. They're all positive. Alright? But I need you to start thinking now. Sine deals with the y's. Cosine deals with the x's. Just start having that association in your mind. So remember over here, in the second quadrant, the y's are positive, the x's are negative. So the sine deals with the y's. So it's y, which is positive, over r, always positive. So it's going to be positive. What about the cosine? X over r, so it's going to be negative. X is negative, r is always positive. What about the tangent in the second quadrant? It's going to be negative, that's right, because the y is positive, but the x is negative. So you have a positive divided by a negative number whenever you do this. Something would be like a positive number here divided by a negative number there. Don't draw that. But let's go down third quadrant. Talking about the y's in third quadrant. Are they positive or negative? Negative. X's? Negative. So the sine, which follows the y's, is going to be negative. Cosine, which follows the x's, negative. And tangent,
Positive.
whoa, why positive?
Because negative divided by negative is positive.
That is correct. The negative divided by negative is a positive. Let's think about fourth quadrant here. In the fourth quadrant, the y's are somebody else, x's are positive. So the sine, which follows, excuse me, so follows the y's, is negative. The cosine, which follows the x's, is going to be positive. And the tangent, anybody?
Negative.
It's going to be negative, because you have a negative divided by a positive. So tangent's kind of the fun one, I think. Positive in the first quadrant and positive in the third quadrant. Turning that double frown upside down, making it all positive. But in these other quadrants, tangent, second and fourth quadrant, tangent is negative because the positive, negative, it's alternating over there. Okay? Go awfully quiet here. It makes me wonder if everybody's getting it. Anybody have any questions on this so far? Let's do some problems and see if we can apply this knowledge. New versions of sine, cosine, and tangent. Yep. Alright, here we go. So this question right here says, let negative 5, 2 be a point on the terminal side of theta. Find the exact values of cosine theta, secant theta, and cotangent theta. Let's just go and draw a picture. Negative 5, 2. 2, 3, 4, 5. And 2. there's the point. This is on the terminal side of angle theta. So all right, and they want us to find cosine theta. And you say, cosine theta? Theta's not even in a triangle. Theta's like outside the triangle. How am I supposed to find cosine theta? Well, relax now. We're just going to use our formulas, okay? The cosine of any angle. You're like, I don't even know the angle. You don't even need to know the angle. We've got the terminal point here. It's kicked over -5, kicked up +2. Somebody read off to me, what's the formula, the new formula for cosine theta? X over R. So x is -5. R is sometimes it's always good to label your x, label your y, and label your r, especially while you're kind of getting into these. Have to find r. Oh no. What tool are we going to use to find r? Pythagorean theorem. There we go. So -5 squared plus 2 squared. Grab a calculator if you don't have one. Equals r squared. 25 plus 4 is 29 squared, 29.
5.39.
Exact answers only?
5.385.64.
Oh, you're still going to round there at the very end. Square root 29 is square root 29.
No, okay.
Alright, so -5 over square root of 29. That's the answer. Alex may want it to be simplified. So I'll write root 29 over root 29. So -5 root 29 over 29. Sometimes they don't require it, I don't know why.
So that's it, that's the answer? Well,
For the cosine, I think so. Let's do a reality check and look at the positive negative. We're saying that it's negative. Does that make sense? Cosine of that angle in the second quadrant is going to be negative. Well, you can look back at your sheet, or you can think about it and say, cosine deals with the x's. The x is negative. Yeah, it should be negative. So yep, that's good for a cosine answer right there. Secant. Somebody call out to me, what's the secant in terms of x, y's, and r's?
R over x.
I think r over x, okay? So the r we determined was root 29. The x, -5. Ha-ha! Already in rational numerator form, or rational denominator form. So we're done with that one. And then they ask us to find the cotangent. I highly recommend you, when you're doing these problems, just go ahead and write down the formula, just to kind of get that in your mind a little more. Cotangent, somebody call it out to me. X over y, you say? Okay. X is -5. Y is 2. That is 2WO. There you go. That's how you use this stuff. Able to find sine, cosine, tangent, secant, cosecant, cotangent of angles that are larger than just 90 degrees. As a table, I want you to draw number 2. Okay, it doesn't have to be exact. It doesn't have to be like totally to scale, but draw that and see if you can find cosine, cosecant, and tangent while I take attendance. Alright, see some good diagrams there. I don't know how far exactly root 5 is, I'm just gonna put it there.
Right.
That's the X. That's the Y. That's the R.
So when multiplying two square roots together, you just multiply the numbers.
Yeah, well, I mean, yeah, so, the square root of 5 times the square root of 5 is the square root of 25.
It will be
Five.
Yep.
So we have 5 plus 4, which is 9, equal to R squared. So R equals 3. I think the hardest part in this problem is honestly the Pythagorean theorem part. Because now we just go over and plug in our formulas here. Cosine is x over r. So that's root 5 over 3. Somebody tell me, what's that ratio for cosecant? John, a little bit softer, please, thank you. Cosecant, anybody? R over x? Or over y? R over y? Okay, so R was 3. Y was -2. So you have to pay attention. You can't just make everything positive for the fun of it. You've got, if y is negative, you got to put negative down there. Okay? The only thing that's positive all the time is that R value. Tangent, y over x, so that's -2 over the square root of 5. And then we'll go ahead and rationalize the denominator. So -2 root 5 over 5. I'm looking at the tangent and it's telling me that it's negative. I can ask myself, is that realistic, having a negative tangent in the fourth quadrant? What do y'all think? Yes, because tangent is the y over the x, and y is negative, the x is positive, so yeah, everything kind of works out. Alright, does anybody have any questions on this so far? Alright, let's keep going. Nick, read to us number 3, please.
Let theta using 1 quarter to
Sine.
Sine theta is 5 over 13.
Okay, keep going.
Find the exact values of secant, theta, and cos.
Okay. Alright, you're really just going to want to draw a picture in almost all of these. Okay? It'll make your life a lot easier. So they say theta is in quadrant 2, so I'll go ahead and draw that. Now they say the sine of theta is 5 over 13, so that's got some hidden information for us. That is telling us that's the ratio of the y value over the r value. So I can go over here and put 5 and 13. I'll label it, there's the y, here's the x, here's the r. Tell you what, let's go ahead and just do Pythagorean theorem just to finish this out. What is that x? X squared plus 5 squared equals 13 squared. So 169 minus 25 is 144 square root. Should be 12. Yep. we've got all the pieces of the puzzle. Let's go ahead and solve the problem. Secant of theta, somebody call out to me, what is secant? R over x. So the R was 13. The x was 12. Ooh, wait a second. Intermediate step here. You had x squared equals 144, right? When you take the square root of both sides, it could be, yeah, it's really plus or minus 12. Up until now, we've always said, just throw out the negative because it's a triangle and it has to be positive, okay? That has been true up until now. And this also is a triangle. However, this side of the triangle is telling us that it's 12, but in that direction, okay? And so, in this case, we're going to throw out the positive based on our picture and realize that that 12 is actually negative. Y'all know that on the x-axis to the left is negative and to the right is positive, right? Okay. So just use that knowledge. Do a reality check while you're working through this before you put those numbers down there. Just realize if we're kicked to the left, that x is going to be negative. If we're kicked down, that y is going to be negative. Cotangent. Somebody tell me that ratio. X over y. So the x value was negative 12. Y value was 5. There's a good answer for us. Alright, as a table, I want you to start working on number 4. Go ahead and draw that picture. I'll be walking around and letting you know if I see a bad picture. Or a good picture. Get a picture? Show me XY axis on all these. I need to see a quadrant 4 picture. Good job. I see. You got the negative. Yep, that's what I see. You got a picture? That's good. Yeah, let's make the whole triangle there. That'd be good. Russ, you got a picture for us there? Okay. It's just helpful to verify. Really good picture. Okay, let's got the negative 12 just marked where you should. Now hold on, that's an x.
Yeah, it's right up here.
X is right up there, yeah.
Yeah.
Oh, you were putting it there like it's at the very end.
Yeah.
I know, I'm with, yeah, so I've got to start putting it in the middle. This is not the correct picture. No, it's going to be going down 5, out 5, the other way around, down 12. Keep that down this way.
All the opposite way.
That's a good picture. Okay, yeah. Negative 12. Diagram here. Make sure you have that 12 is negative.
That's negative. I know it's negative because it's going down. You don't need to see triangle. It's just that, yeah.
Even though theta, so that, notice this says negative 12 over 13, so I know that that 13, which is the R, has to be positive, it always is, so that 12 is the y value, the negative 12. This is that same Pythagorean triple as we saw a moment ago, 5, 12, 13, so you could also do the Pythagorean theorem, but you'll find out that x is equal to 5. But you'll still get that plus or minus situation, plus or minus 5. Looking at the diagram, we see it's kicked out to the right, so that means it's going to be 5. So somebody tell me, secant of theta is what over what?
R over.
R over x. So 13 over 5. And tangent of theta is y over x. So that's going to be negative 12 over 5. You've got to pay attention to your signs, folks. Sign S-I-G-N. Okay? That's your plus or minus. Okay? That's going to make a big difference. Alright? We're going to hit the pause button on there. Stick a pin in it until tomorrow. Can't think of any more expressions there. Okay? Somebody tell me one or two things that we talked about today.
We learned that we use Y, X, and R.
Use y, x, and r. Somebody else. Rosa, something we talked about today. Be more specific. What about the reference angles? Okay, how to use reference angles and those trig ratios. Okay. We're not totally at the point where we can find them, these angles all by ourselves, but we're getting closer. Okay? Alright. We'll wrap up the rest of those practice problems tomorrow, maybe finish early, and then have a work day for the rest of tomorrow and all day Friday.